This video lesson deals with section 3.2 part 1, addressing relations and functions. So for the warm-up, you're asked to generate ordered pairs for the function y equals x plus 3, and then graph the ordered pairs. So it's important to know what it is you need to do in order to generate ordered pairs. Well, notice we have an xy table here on the left-hand side, and it's giving us a series of x values that you need to use. So in order to figure out the y's, we're going to take each of these x values, substitute them in to our function, and then figure out what the associated y would be. So for example, if I'm plugging in -2, that's for x, I would write y equals -2 plus 3. So then that gives me y equals 1. So when x was -2, it gave me a y value of positive 1. Same thing for the next one. When x is -1, we plug -1 in for x. So that's going to say y equals -1 plus 3, which gives us a y value of 2 when we plugged in -1 for x. Okay, so we are taking these x values and plugging them in where we see the x to figure out what y's go with them. So please finish the rest of our table by plugging in the x values of 0, 1, and 2, and then plot your ordered pairs on the coordinate plane. So check out your results. When you plug in 0, you should have gotten a y value of 3. Plugging in 1 for x, you should have gotten a y value of 4, and 2 for x gives you a y value of 5. And here are those 5 ordered pairs that are plotted on the coordinate plane. Okay, so they do in fact make a nice straight line if we were to connect the points, but there's nothing at this point in time indicating that we should connect the points. So generate the ordered pairs, graph the ordered pairs. So our goals for today are to be able to identify functions and to find the domain and range of relations and functions. Important vocabulary words: relation. A relation represents relationships through a set of ordered pairs. Okay, so relationships represented through ordered pairs. We can represent relations using actual ordered pairs in an XY table. We could represent them as plotted points on a graph, which again, still ordered pairs, or we can use what we call mapping diagrams. Domain is the set of the first coordinates, or the x values, of our ordered pairs. The domain is sometimes also called the input. Okay, so domain is the x value or the x values, and also known as input. The range, on the other hand, is the set of our second coordinates, which would be the y values, also known as the output, or the result that comes out of plugging in an x value. And then we have function. A function is a special type of relation where every x has exactly one y. Okay, so a function is a very special and specific type of relation where every x has only one y. So here is a model of expressing relations using a table, a graph, and a mapping diagram. Okay, so the relation has a series of ordered pairs listed out here. And then those ordered pairs were written in were written in a table, plotted on a coordinate plane, and then this mapping diagram. How does the mapping diagram work? Well, notice the x, the first column here deals with your x's, the second column deals with your y's, and then what happens is you literally just put each of your x values in smallest to largest, you put your y's in smallest to largest, and then you draw arrows from the x to its associated y. And this particular problem, it just worked out that each x was directly across from its associated y, but that won't always be the case. So we're going to create our own table, graph, and mapping diagram for the relation listed here. Okay, so with our XY table, the X's are going to be what dominates, and we need to make sure we put our X's in order from smallest to largest, and then make sure we buddy up its associated Y with it, regardless of what that Y value is. So if I look at these ordered pairs 1, 3, 2, 4, and 3, 5, the X coordinates 1, 2, and 3, they're already in order. So I'm just going to list these ordered pairs in the exact order that they are already written. So 1, 3, 2, 4, and 3, 5. If we're graphing it on the coordinate plane, we've got X is 1, Y is 3. Okay, so these are X comma Y's. Okay, so that means I'm going to go right 1 and up 3 to plot the ordered pair 1, 3. I'm going to go right 2, up 4 to plot the ordered pair 2, 4. And then I'm going to go right 3 and up 5 for the ordered pair 3, 5. So our mapping diagram is already set up. We've got two little ovals there for our 3 ordered pairs. So the X's go in the left side, the X side, or the input. So my X's here are 1, 2, and 3. So that's already in order. My Y's go in the other oval here. So my Y values are 3, 4, and 5, and those are also already in order, smallest to largest. And now we just need to make sure that we draw lines that are connecting their relationship, that are establishing that relationship, connecting each X to its specific Y. So 1 goes to 3, 2 goes to 4, and 3 goes to 5. And again, we've got another straight across relationship, which we need to make sure we get one that's not straight across. But I'm sure that'll happen a little bit later on. So again, as noted earlier with our vocabulary, the domain of a relation is the set of the first coordinates, or those X values. And the range is the Y's. So domain is X, range is Y. So if I'm looking specifically at domain and range for these different scenarios, I've got a graph, I've got a mapping diagram, and then I've got a table. We want to just make sure that we are, in fact, speaking only about X values when asked about domain, and only Y values when asked about range. So I'm going to skip number 2 for now because that's a continuous graph. So that's going to require a little bit of interval notation, which is a little trickier. So we're going to start with number 3. And remember, with the mapping diagrams, okay, X is our first column, rectangle, whatever it may be. Y is your second. Now notice these first 2 mapping diagrams are in order from smallest to largest in X and Y's. In 3, for some reason, the X's are going from largest to smallest, and the Y's are going smallest to largest. I prefer small to big, okay, so whatever, but this problem is the way it is. So we're going to follow what it has here, and the domain is still going to be that left side, regardless of how the problem is presented. So the domain is the X, and we're going to list out the domain in order from smallest to largest. So we're going to put some brackets here. So the domain, the X values are 1, 2, 5, and 6. The range then is the Y values, and those are the Y values of -4, -1, and 0. Okay, so now technically speaking, if I was asking you, well, what are these ordered pairs? Well, the ordered pair with my x value of 6 is going to be 6 comma negative 1. Okay, so the x of 6 goes with y of negative 1. The x of 5 goes with the y of 0. The x of 2 goes with the y negative 4. And the x of 1 goes with the y of 0. Okay, so those are the ordered pairs that come out of that relation. Looking at number 4, domain is x. Okay, so x is our first column. We've got 1, 4, and 8 serving as our x values. List them in order. And the y's are 1, 4, and 1. Now we're not going to repeat any x or y values when we're stating what our domain and range consist of. So that means for range, I'm only going to say, well, my y values consist of 1s and 4s. Okay, so do not list it multiple times. Now for number 2, going backwards, our domain is, again, our x values. And if we look at our x values, okay, I'm going from left to right. Well, what are these left and right x values here from this line? Well, the farthest left x value, so the smallest x value, is positive 1. The largest x value is over here, okay, at positive 5. So our x is everything from 1 to 5. So we're going to write an and sandwich to say that. 1 is less than or equal to x, which is less than or equal to 5. So our x's go from 1 to 5, and it is included because the ordered pair 1, 4 is an actual defined point. Okay, so 1 is included, as is the x value of 5, which is the ordered pair 5, comma 3. So domain is x's left to right. Range is y's, so top to bottom, or specifically if we're going small to big, it would be bottom to top. So we want to figure out our smallest y value up to our largest y value. Well, our smallest y, our lowest point, is the y value of 3. Our highest point is the y value of 4. So our y is sandwiched in between 3 and 4. And every y value in between, 3.1127, 3.7341, all those y's are included here somewhere. Okay? So when it's a continuous graph, we're going to have to use interval notation. And a lot of times I'll make an actual box to help see the left, right, bottom, and top. Okay, moving along to our definition again of a function. A function is a special type of relation that pairs each domain value with exactly one range value. So every x has exactly one y. So we're going to take a look at these next couple problems and identify the domain and range, and then decide whether or not we have an actual function. Okay, so I like these ordered pairs and the way these are listed out a little bit better than the initial ones, because the initial ones weren't scrambled. They were already in order, right? So these particular ordered pairs are scrambled, so we're going to make sure that we put things in the appropriate order as we go about determining our domain and range. So our domain is the x values. I'm going to try to use the same colors. So I've got a 3, 5, 4, and 3. And remember, we don't repeat. We want to go in order from smallest to largest. So that means my domain is going to be 3, 4, and 5. The range is the y values. So -2, -1, 0, and 1. Well, those are actually in numerical order, so that's nice. So -2, -1, 0, and 1. Now the question is this a function? Okay, thinking about for every x there is exactly one y. So we're going to watch out for repeated x's. Okay, so if there's any x value that is repeated, that would imply that it's going to more than one y, and therefore not a function. So if we take a look at this, 3, -2, and 3, 1, that x value of 3 has more than one y value. It has two different y values. So this particular relation is not a function. Therefore, it's a relation only because x value of 3 has two y values. Now, how would that look in a mapping diagram? Well, let's make a little mapping diagram. I'm going to make two rectangles. All right, so I'm going to fill in my domain and range in my rectangles. Okay, so X is the first one. We're going to go right in order, 3, 4, 5. Y is my second rectangle or oval or whatever your shape will turn out to be. Again, those go in order, smallest to largest, so -2, -1, 0, and 1. And now when we do our mapping, I like this one because it's not straight across. Positive 3 goes to -2. Okay, so there's our first one. Then we've got positive 5 goes to -1. So 5 goes up here to -1. 4 goes to 0. And then 3 goes to 1. So notice in this mapping diagram, which we said it's not a function, we've got an x value here of 3 that is going to two y values. Okay, so that's a different, more visual way of showing and determining whether or not we have a function. Okay, so if there's more than one line coming out of an x, not a function. So let's move on to number 6. Our domain is our x values, our first rectangle-ish. So putting them in order, the numbers in order. -8 would be the smallest, so that comes first. Then -4, then positive 4, and positive 5. Range, our y, our second part of our mapping diagram, is only two y values, 1 and 2. Now here's the thing with functions. We only care about what the x's are doing. It doesn't matter what the y's are doing. So if you look at the y's, right, there's only two y's, and we've got multiple arrows going into each of them. However, in order to determine whether or not we have a function, we need to decide, does every x have exactly one y? Well, -4 is only going to one number. Don't care what it is. -8 is only going to one number. Don't care what it is. 4 is only going to one number. 5 is only going to one number. So each of our x's are technically only going to one y value. Okay, and again, it doesn't matter what the y value is as long as there's only one y value for each x. So this is a function because each x has exactly 1y. Okay, so using 5 and 6 as examples and models, I would like you to complete numbers 7 and 8. In checking our answers, hopefully you got that number 7 is a function because every x has one y. Okay, so our domain was -6, -4, 1, and 8. Our range was 1, 2, and 9. And I also displayed it in a mapping diagram to help visualize. In number 8, we have a mapping diagram. Our domain is 2, 3, and 4. The range is -5, -4, -3. Due to the fact that the x value of 2 is going to 2 different y values, this is not a function, it is only a relation.